Welcome back. It's the night class. I'm Coach Knight. Today we're doing 4-2, which is quadratic equations. Hopefully you remember quadratic equations. There's Mark McGuire. He liked hitting home runs. Quadratic equations are an equation where the exponent, what's the highest exponent? A little higher than 1. 2. Okay. Example 1 has a quadratic equation. All right. X squared. When you were doing your standard form, it's ax squared plus bx plus c. Okay, those are quadratics. In Algebra 1, you deal with them a whole bunch. Algebra 2, of course. So this should be all review. There's factoring to solve them. You can solve them by the quadratic formula. That's the negative b over, or negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that whole big thing. So quadratic formula, factoring, you can graph it. Okay, this one is a picture of it being graphed on your calculator. You're looking for where it crosses the x-axis. Those are your answers. Okay, those are called your zeros. And there's also something called completing the square, which you learn in Algebra 1, but you don't really have much use for it. We're going to use it today. Anyway, those are your 4 ways of solving quadratics. Only 2 of them always work. Okay, the 2 that always work are the quadratic formula and completing the square. Okay, you can always solve it using one of those 2 methods. All right, factoring only works if you can factor it. Sometimes you can't factor it. And graphing only works if your answers are real. Okay, so if the answers are real, they will cross the x-axis. If your answers are imaginary, they won't cross the x-axis. The graph won't cross the x-axis at all. Okay, so we're going to start off simple. This one, I would have graphed. Okay, I'm going to graph all of them that I can because that's the quickest and easiest way. As you can see, it looks like it's crossing at what there? X equals -2, and over here we got 1, 2, 3, 4, 5, 6, 7, 8. So those would be my answers, and that's just me plugging it in and seeing where it crosses. Okay, I'm also going to do the other quick and easy, which is factoring. Factoring is when you use your zero product rule. So we factor first. We need 2 numbers that multiply to be -16 and add up to -6. So what 2 numbers would multiply to be -16 and add up to -6? -8 and +2. And the zero product rule says that the only way to get 0 when you're multiplying is for one of the numbers to be what? 0. Okay? If you multiply 2 numbers and neither one of the numbers are 0, you will never get 0. Okay? The only way to multiply and get 0 is for one of the numbers to be 0. So this parentheses could be 0, or that parentheses could be 0. We don't know which one, so we have to work it for both of them. Okay? And basically you just set them both equal to 0. So x minus 8 equals 0, x plus 2 equals 0, and basically your x just ends up being the opposite of those factors. Okay? These are called your roots, your zeros, solutions. I'm trying to think what else they could be called. X-intercepts. Okay, all of those mean the same thing. Okay, they're x-intercepts because that's where they cross the x-axis. Okay, they're zeros because that's what makes the problem equal to 0. Okay, I'm not really sure why they're called roots. Somebody look that up on Google for me and let me know. Okay.
That's where the graph is rooted in x-axis.
That sounds really good. Let's go with that. All right. So, as you can see, we get the same answer no matter if we factored it or if we graphed it. We get the same answer. Okay. This one you may not quite remember. Completing the square. Notice they graphed it for you right here. What is it not crossing? That's not the y-axis. The x-axis. So if it doesn't cross the x-axis, you know your answers will be imaginary. Okay? Everybody knows what imaginary is, right? Square root of a negative. Okay? So you're going to have imaginary answers here. All right? Now, We talked about this very little the other day, but how many answers am I going to have total? 2. That's what the degree tells me, okay? And remember, does anybody remember what kind of, like, the imaginary answers, they have to come in what? Do y'all remember? Pairs, okay? So right here, you can see we have no real, which means we have to have how many imaginary? 2, because the total of them have to add up to 2, okay? So, to complete the square, and I'll be honest, I don't like this example because I would never choose this to be a completing the square problem. I would do this by the quadratic formula, okay? Because you're doing a lot of extra work here, all right? But this is the hand we're dealt. We're gonna deal with it, okay? So first step, when you're completing the square, the a has to be 1, okay? So this number, this coefficient in front of your quadratic term, it has to be 1. So how can I make that 1? What can I divide by? 3. But golden rule of algebra, if you do it to one thing, what? You have to do it to everything, okay? So that will now be n squared plus 7/3 n. I'm actually going to move the constant over. So I will make that negative 7/3 over there and leave this blank, okay? So I moved the 7/3 right here. Oops. Okay. I subtracted it over. All right. Completing the square is also the only method that you do not want the equation equaling 0. Okay. You want it equaling some number. All right. Now we are going to complete the square. You do it in 2 steps. Okay. You take whatever your b is and you divide it by 2. And then you square that answer. Okay? B divided by 2 squared. So what is my b? 7/3. So 7/3 divided by 2 is. Now, that looks really hard. It's really not, though. When you're dividing a fraction by a whole number, you just multiply the 2 bottom numbers. So that's basically 7 over what? 6. And then what do I do with that number? Square it. So 7 over 6 squared, 49 over 36. Okay? If you put it in your calculator, it'll give you a big long decimal. So try to just do it in your head if you can. So, okay, 7 squared is 49, 6 squared is 36. That's the number we're going to add on both sides. So plus 49 over 36 here, plus 49 over 36 there. Okay? Can y'all see that?
Why did you do that?
Why did I add it?
But why did you find it in the first place?
Because this is the process of completing the square. Completing the square means I'm trying to make this trinomial a perfect square trinomial. Okay? I'm trying to make it, if it would literally, if it was a shape, I want one side of the square to be the same as the other side. So that's kind of what the goal is here. Okay? And you'll see how it works when I factor it. Now I can factor it. Okay? And now there's a trick to factoring. Up there, we had to figure out 2 numbers that multiply to be negative 16 and add up to negative 6 or whatever it was. Okay? So I'll be honest with you. I don't know what 2 numbers multiply to be 49 over 36 and add up to 7 over 3. Okay? But it's the same thing every time. You see this number I got when I divided it by 2? This 7 over 6? That's your number. It's going to be n plus 7 over 6 times n plus 7 over 6. Now let me show you how this works. 7 over 6 times 7 over 6 does give you what? 49 over 36. And if you added them together, 7 over 6 plus 7 over 6 is 14 over 6, which reduces to 7/3. Okay? So whatever you get when you divide by 2, that's going to be your factors every time. Okay? Now notice, they're the same factor, right? That means they are a perfect square. So 7 plus 6 squared equals. Okay? We didn't do this over here. 7/3 over, or negative 7 over 3 plus 49 over 36. So what would that be as a fraction? Let's not make things hard and just use our little calculator. 7/3 plus 49 over 36. You get a big decimal, negative 0.97222. You think I want to use that? Nope. Hit math. Enter, enter. You get negative 35 over 36. And that's good. From here, it's just doing stuff you know how to do already. So how do I get rid of the square? I take the square root. That will be n plus 7 over 6 equals plus or minus square root of 35. Can we take the square root of 35? No. Okay. It's just going to stay square root of 35. But it's negative 35. So what comes out front? I. So it's I square root of 35 over, what's the square root of 36? 6. And then our last step is we move the 7 over 6 over. So subtract 7 over 6. Our final answer will equal negative 7 plus or minus I. Got the I. Square root of 35 over 6. Okay? Now, how can I write it all as one thing here? Because they have the same what? They have the same denominator. Okay? Yes, sir. Sure. They have the same denominator, so I can write them as one fraction. Really, I would be writing it negative 7 over 6 plus or minus I square root of 35 over 6. But I can combine those because they have the same denominator. Okay? That should remind you of your quadratic formula. Okay? Usually you get something plus or minus something over something. Okay? There they are. All right? You would need to reduce your square root if you can, but you can't simplify that radical. 35 would just be 5 and 7, nothing repeats, so it stays like that. Okay? And we'll do more coming up. All right?
That is a lot to remember.
It is.
That's why I wrote it all down.
Yeah. Hopefully everyone did. So we've done a graphing, we've done a quadratic form. We have not done a quadratic form. We've done a graphing, a factoring, a completing the square. Let's do a quadratic formula. Okay? I'm sorry.
Please don't be harder.
It's not. Well, it's not harder.
Yeah.
You will write that, and you will understand.
I will do it later.
Reason to force.
This is a video. I can.
Oh, that's true.
I'm just trying to get it. Come on.
You will get it.
Oh.
Remember that time you did a brain scan?
I'm Coach Knight. Jedi is my middle name.
Do you remember that time I did pretty bad on like 2 tests in a row, and then you did a brain scan, and I made like a 99,
I do remember that.
and then it never worked again.
Everybody good? Okay. As long as it worked once.
Have you done the bottle trick this year?
I haven't.
You haven't?
I haven't. My kids said I need to do it so I can put on a highlight reel to be like the,
It could be your like
the intro, right? The intro.
and the llama and all that. Oh, the llama.
Yeah,
There's
yeah.
a handstand one too. I'm pretty sure.
Okay.
There is a handstand one.
All right. Don't give them all away. All right. Number 4 says find the discriminant of x squared minus 4x plus 15 equals 0 and describe the nature of the roots of the equation. Then solve the equation by using the quadratic formula. Again, they graphed it for me here. I know the nature of the roots. When they say what is the nature of the roots, they're saying what kind of answers are you going to have? Are they going to be real? Are they going to be imaginary? What are they going to be? Okay. Notice they graphed it. Did it cross the x-axis? No. Therefore, they will be imaginary. We're going to have 2 imaginary. So, if you have forgotten, the most, well, it's a close race for most important formula to memorize, okay? That one and the Pythagorean theorem are probably the 2, you got to know them, okay? This is the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, some of you said, is this harder? I don't know. It's plugging in, okay? That's really all it is. the discriminant right here, you see that word? The discriminant is the part under the square root. Okay? It's the part under the square root. So understand, it's not the square root itself. It's what's under the square root, the b squared minus 4ac. All right? Just the b squared minus 4ac. So if they're ever asking you, just tell me what kind of answers you're having, you don't have to do the whole thing. You just have to do the b squared minus 4ac, and it will tell you what kind of answers you're going to have. Okay? If b squared minus 4ac is negative, if it's less than 0, they're going to be 2 imaginary. Okay? Whoa. All right? 2 imaginary. If b squared minus 4ac equals 0, there's 1 real answer. And if b squared minus 4ac is greater than 0, which means is it positive, you will have 2 real answers. Now, hopefully, your first question is, how can it only have 1 real answer if it's a quadratic? Because if it's a quadratic, how many answers are we supposed to have? 2. Okay? Always are going to have 2. 2 real or 2 imaginary? Well, technically, the one that you only get 1 real, you get the same answer twice. Okay? So like x equals 6 is an answer, and then x equals 6 is another answer. Okay? So that's why they're only saying 1 real there, but really that one answer occurs twice. Okay? So let's do it. I would not be doing the entire thing if it didn't say then solve the equation by using the quadratic formula. So I'm just going to get my discriminant as we go. All right? So x equals negative. And people get tired of making their little parentheses, but if you put parentheses and then take it step by step like I'm showing you, you won't get it wrong. Okay? I literally replaced every letter with a what? With a parentheses. That's negative b plus or minus b squared minus 4ac divided by 2 times a. All right? Put parentheses everywhere you see a letter, and then go plug in what they are. Okay? Before you plug in what they are, your equation needs to be equal to what? 0. Our equation is, so we're ready to go. What is b in my equation? Negative 4. So I plug in negative 4 there, negative 4 there. What is a in my equation? 1. And what is c? 15. And from there, it really is just simplifying. Okay? I simplified in 3 stages. I do this part right here. A negative 4 is 4. Over. I do the bottom. 2 times 1 is 2. So we have plus or minus the square root of, I do that part under the radical by itself. So what is negative 4 squared minus 4 times 1 times 15? 4 times 15 is 60. So negative 60 plus 16. What's negative 60 plus 16? Negative 44? That is also, I believe, correct. Okay? So my discriminant is what? Negative 44. Not the square root of negative 44. Negative 44. Everybody understand? Do not include the square root with your discriminant. Okay? The discriminant is the number under the square root. All right? It's negative. So I'm going to have how many? What kind of answers? 2 imaginary. I'm going to have 2 imaginary answers because it's negative. Okay? So discriminant is negative 44. I will have 2 imaginary answers, and then they want me to solve it. Okay, so to solve it, all we have to do is simplify this. I know since it's negative, what am I going to pull out front? An I. Okay, can I reduce square root of 44? I think so. I don't know how your teacher taught you, or if your teacher taught you at all, but I'm going to show you. To simplify your radical, you make what's called a factor tree. Okay? If it's an even number, I always start with, what do you think? 2. So 2 times 22. I can continue. 2 and 11. Can I continue? No. Whatever you have a pair of, you can bring out front. Okay? So I have a pair of 2's. Because what's happening is, I'm saying the square root of 4 times the square root of 11. 4 times 11 is 44. But what's the square root of 4? 2. So that's why you get to bring out a 2. Okay? So that will equal 4 plus or minus 2i square root of 11 divided by 2. And then can you reduce? 4, 2, and 2. Can you reduce those? You can divide all that by what? 2. So my final answer will be 2 plus or minus I square root of 11.
And the reason you have 2 answers is because of the plus and minus?
Correct. Did y'all hear what she said? The reason you have 2 answers is because you're adding and subtracting. Okay? Don't think that's one thing. That's one time you're adding it, one time you're subtracting it. That's just saving time writing it. All right? If you notice in the book, there's one root, there's the other root. Okay? Yes, ma'am.
We were simplifying radicals in geometry,
Yes.
and a lot of people couldn't figure it out, and I showed them your way, and a lot of people got it.
Good. Awesome. My ways, it may take a little longer, but it's the simplest of the
I don't
ways.
understand how you used to do it in your head.
Well, the other way of doing it is you have to be really good at knowing what your perfect squares are.
And I don't.
And a lot of people don't. So, now, I do want to talk to you about these 2 things. Your imaginary answers, I told you, will always come in pairs, and they will always be related. They will always be the same, just one will be positive, one will be negative. Okay? And those are called conjugates. Okay? Everybody understand that? And if you're talking about solutions, they always come in pairs. So if I tell you, hey, one solution to that is 6i, without even me telling you, you should know another solution is what? Negative 6i. Okay? It always works like that. If one solution is 5 minus 2i, there's another one that's 5 what? Plus 2i. Does everybody understand that? They always come in pairs. All right? All right. Let's try some on our own. This is where I leave you video people. Hope y'all have a great day. As always, stay above the line.